Hey guys, this is the notes for day 3 and day 4. We're creating box and whisker plots. This may be new for some of us. It says it's a display that shows the distribution of values in a data set separated into 4 equally sized groups. A box plot is constructed from a 5-number summary of the data. So the box plot is the inside, it's the middle 50% of our data, and each of these are equally spread apart, and they're 4 equally sized groups. So if the whole thing is 100, each is 25%. Okay, so I'm gonna go ahead and label that. So from here to here is 25% of my data. I don't know if they've surveyed 100 people, 1,000 people, or maybe just 10, but 25% of their responses fell within our 34 to our 58 right here. This lower quartile, you may also see sometimes abbreviated as Q1. Then another 25% of their data answered from 58 to then the median was 62. The median, in terms of box and whisker plot, you may see abbreviated as Q2. Another 25% of their data would have then fallen between my 62 to the 69. This upper quartile is what we call Q3. And then my maximum value, you may have guessed it, is quartile 4, where 25% of my data falls. Okay? So again, I don't know how many people they surveyed, but if I chunked my data, 25% of the responses are in each one of those 4. Another vocab word for you to know is my interquartile range. So that's the difference between the upper quartile, and there's my abbreviation Q3, versus the lower quartile Q1. Okay, so I'm making a note to myself to remember. So it's Q3 minus Q1. So for example, that one we just looked at, the upper quartile is 69, the lower quartile is 58, so the difference between them was 11. This is another example of how we can measure spread. So remember we said the median was a middle measure of central tendency. The interquartile range is a measure of my spread. So let's do an example so we can see how this all fits together. It says make a box and whisker plot for the shoe size of people in your class. So I just went ahead and made a random list of the smallest shoe size, maybe of a toddler in your room, versus the big size of a 6-foot man. Okay. My first step when I do the project though is I need to put them in order like what you see here. So to find the middle, I need them order from smallest to biggest. 3 and 14, 3.5 and 13, 5 and 12.5, 6 and 12, 7 and 11.5, 10 and 11. I lucked out. I have a median here of 10.5. Okay. I would hesitate from crossing them off as you go today, because we're going to end up doing that same thing for the lower percent of the data and the same thing for the upper percent of the data. So as you're counting your median, just go ahead with your fingers, work your way towards that middle. If there are 2 numbers in the middle, then we have to add them up and divide by 2. So right now, we're looking at the median is 10.5. That separates my data. So 50% is over here, 50% is over here. In order to find the lower quartile, that's the lower 25%, I have to cut this range in half. If you had split this down the middle, and there was an even number, I would include that number for this lower quartile, and I would include that number for the upper quartile. Since we truly had a median though, we're gonna cross that one off. My lower quartile is based off of these 6 numbers right here. We're gonna do the exact same thing as the median. 3 and 10, 7 and 3.5. So for my lower quartile, we're looking between 5 and 6. So for the average, I add those 2 together, I press enter on my calculator, then I divide by 2. So my lower quartile would be 5.5. Same thing for my upper quartile. 11 and 14, 13, 11.5. I'm looking between these 2 numbers for my upper quartile. So I need to add them. Make sure I push enter, because order of operations, my calculator otherwise will just divide the 12.5 by 2. I need to add those 2 first, divide by 2. My middle should be 12.25. The minimum and the maximum are just my smallest number, my biggest number in the list. So my smallest number was 3. My biggest number was 14. Okay. The hardest part is when I go to draw the picture down here for my number line. Okay, so I want a normal number line. I need to be able to see all of these numbers, not necessarily just graph the ones I have. So if my smallest number was 3 and my largest was 14, I'm just going to go ahead and start at 0. Make sure I get all the way to 14. And go a couple past. Okay. For the project, you'll be given a number line. So make sure they're equally spaced out. And now I can start to graph. So my minimum was 3. I'm going to go and put a dot there. My maximum was 14. I can put a dot over there as well. So then my quartiles, the median, the middle of my data was about 10.5. My lower quartile was at 5.5. And then my upper quartile was slightly more than 12, so about 12.25. So what we consider to be the box is the middle 50%. That's also what we call our interquartile range. So the middle 50% of our data. The true middle was 10.5, but my middles from both of those two 50% was 12.25 and 5.5. So that middle 50% of my data is when I subtract those two numbers, and I can just visually see it's where my interquartile, and it's what makes that box. 12.25 minus 5.5 should give us 6.75. Okay. And then I can connect the rest of my box. So here's my lower, and then here's my upper. Okay. So again, doesn't look symmetrical. Just looking at my box and whisker, I can't tell if I surveyed 100 people, 1,000 people, maybe just 10. Okay. But from here to here, I had 25% of my data. We know from looking at it, there was 3 people that answered between 3 to 5.5. Then my middle quartile got to 6 to my 10, and then 10.5 to over here, my 12.25. I had 3 numbers fall within there as well. And then my upper quartile is these 3 numbers right here, if I put it on a line plot. When it comes to the project though, your conclusions are based on your box and whisker plot. So don't give specific details of certain people answering each one. If you're simply looking at the box and whisker plot, your conclusion is that 25% of the people answered here, 25% were in this quartile, 25% here, and 25% here as well. Remember, this is the measure of spread, so it's just a visual to see how spread out my data is. The bigger that box is, the bigger my data was spread out within there. There could have been a lower, there could have been higher, anywhere within this box, but there was a bigger range, meaning my data was more spread out in the lower quartile than compared to my upper over here. Okay, I know that was a lot of new information. Feel free to hit pause. You can go back, rewind, watch any of this again. Okay, when you're ready, the practice for day 3 is on the table.